Welcome back to Bhagaskara Labs. Let's start with a scenario. Imagine you have an important server running in AWS. For security reasons, it lives in a private subnet without any public IP. That means it's safe from the internet, but also means you can't just connect to it from your home or office. So the question is, how do we securely access this private server from anywhere in the world? Opening SSH or RDP to the internet is risky. Attackers could try brute force or exploit vulnerabilities. What we need is a secure, encrypted tunnel that only authorized users can pass through. And that's where AWS Client VPN Endpoint comes in. In this video, we'll build an end-to-end solution. We'll generate certificates with EasyRSA, upload them to AWS Certificate Manager, create and configure a Client VPN Endpoint associated with a private subnet and set authorization rules, and finally connect from our laptop with the AWS VPN client. By the end, you'll see how easy it is to create a secure remote access into AWS without exposing your servers to the internet.
All right, let's begin our journey by creating the foundation of our network. Open the VPC console in AWS. Here, we'll create a brand new VPC with the CIDR block 10.0.0.0/16. Think of this VPC as our own private data center in the cloud, an isolated network where we'll place our servers and VPN endpoint. Next, inside this VPC, we add a private subnet with the range 10.0.1.0/24. This subnet will host our resources that should never be directly exposed to the internet. And here's the key point. We don't attach an internet gateway. That's intentional, because our goal is to access these private resources only through the VPN, not through the public internet. With our private VPC and subnet ready, it's time to bring a server to life. Head over to the EC2 console and click Launch Instance. Choose your favorite OS. Amazon Linux 2 or Ubuntu works perfectly. Now, make sure to place this EC2 inside the private subnet we created earlier. And very importantly, do not assign a public IP. This ensures the instance remains completely isolated from the internet, only reachable via our VPN later. Next, we attach a security group. For now, allow SSH on port 22, but don't open it to the world. Later, We'll restrict this access to only the VPN IP range, so only authorized users can connect securely. Now that our network and server are ready, it's time to set up the keys to the kingdom, digital certificates. First, download EasyRSA from GitHub, the link is in the video description, and extract it to a folder on your laptop. Open CMD, run as administrator, and enter into the EasyRSA folder. I've added the exact commands in the description so you can follow along step by step. With EasyRSA, we'll generate a certificate authority, a server certificate and key to identify the VPN server, and a client certificate and key to identify your laptop as an authorized client. Think of these certificates like a secure passport system. Without them, no one can enter the private subnet. With our certificates ready, it's time to hand them over to AWS so it can recognize and trust our VPN connections. Open the AWS Management Console and go to Certificate Manager. First, upload the server certificate, including the CA certificate, the public server certificate, the private server key. Next, upload the client certificate as well. Once uploaded, make sure to copy the ARN values for each certificate. We'll need them in the next step when creating the Client VPN endpoint. Think of this process as registering the passports in a secure immigration system. Now AWS knows which certificates to trust, and our VPN can start recognizing authorized clients and servers.
With that in place, we're ready for the heart of our setup, creating the Client VPN Endpoint that will allow secure access into our private subnet. Go to VPC, Client VPN Endpoints, and click Create. Here, select the server certificate ARN we uploaded earlier. This tells AWS which certificate the VPN will use to identify itself. Next, set the client CIDR range, for example, 10.100.0.0/22. This range defines the virtual IP addresses assigned to VPN clients when they connect. You can also enable split tunnel if you want only AWS traffic to go through the VPN, leaving other internet traffic untouched. Once the VPN endpoint is created, we need to add an authorization rule to allow access to our VPC's CIDR 10.0.0.0/16. and associate the VPN endpoint with the private subnet we created.
Let's put everything together and test our VPN connection. First, download the OVPN configuration file from the Client VPN Endpoint. Next, open the file and embed your client certificates directly inside. This allows the AWS VPN client to authenticate securely. Before we connect, open SSH port in your EC2 instance to the VPN CIDR range 10.100.0.0/22. Open the AWS VPN client on your laptop. Import the configuration file and click Connect. This time, you'll see something new. Your laptop receives a VPN IP address, assigned from the client CIDR range we defined earlier. In my case, I got 10.100.0.162. This IP becomes your identity inside the VPC. It's as if your laptop has been virtually teleported into the private AWS network, just like another server sitting inside the data center. From this point on, you're no longer an outsider. You're securely inside the VPC, able to reach private resources. With this secure tunnel established, let's try SSH. Now when you connect to the private EC2 instance, the connection succeeds for the very first time. You're inside the server, securely, privately, and without any public exposure.
And that's it. We've successfully built a secure AWS Client VPN endpoint connected from our laptop and access to private EC2 instance without ever exposing it to the internet. Remember, in cloud environments, security is all about minimizing exposure. By keeping your servers inside private subnets and only allowing access through a VPN, you reduce attack surfaces and ensure only trusted users can connect. If you found this tutorial helpful, don't forget to like this video, subscribe to Bhagaskara Labs, and turn on the notification bell so you won't miss our next deep dive into cloud security and infrastructure. Thanks for watching, and see you in the next video.